Number 6.
Answer boy, right?
Number 6. A.
Oh, okay.
Right? You have to go back to the equation. Work it out. The root mean square is inversely proportional to mass. So this one is greater mass. Greater mass, smaller root mean square speed. So root mean square speed is roughly an estimate of the peak. Peak is smaller. Heavier, this is smaller. So this is the answer. Okay with that?
Oh, okay.
Root mean square speed. You want to find what is the root mean square speed of hydrogen molecule. Answer is B. Pressure is given, density is given. Let's use the formula. That formula, memorize it. Put in your value. Subject your root mean square. Put in your value and calculate out. Can
Can
a fixed mass of an ideal gas is at room temperature? Which of the statement is not true about the gas if the mass of the gas molecule is m? Okay, basically kinetic energy per molecule is given by that. If it's diatomic, 5 degree of freedom, put inside your value, inside your F there, you get kinetic energy is 5/2 RT. A is correct. Rotational kinetic energy of molecule for gas is kT. Rotational for rotation, there are 2 degree of freedom. 2 degree of freedom, each degree is half kT. So 2 degrees kT, correct? Number of degree of freedom of molecule of gas is 5, correct? Right? 3 for translation, 2 for rotational. Then same D, you just look up, use the formula. So there is no answer here. Even though the book give the answer as donkey. All correct. Okay.
Oh,
All correct.
okay.
Okay with that? Okay, we go to the next one. I thought you are supposed to do
Question error lah.
you're supposed to have done all the questions and asking me those you don't know how to do. Not going over the whole thing.
Okay. Number 9 donkey, right?
Which statement is true about degree of freedom of gas molecule? Total degree of freedom for translational motion of monoatomic gas at room temperature is 1. Wrong. It should be 3. Total degree of freedom or rotational motion of monoatomic gas molecule at room temperature is 3. Rotational for monoatomic is none, not rotational. False. Total degree of freedom of translation of the atomic gas molecule at room temperature is 5. No, you want translational only. Total is 5, correct, but you want translation only 3, so false. Total degree of
Translational first, then rotation.
total degree of freedom of rotational motion of the atomic molecule at room temperature is 2, correct? The answer is donkey.
Okay. Yes. Number 13.
Number 13. You can find that this topic will come out in objective. Okay. Two container X and Y are filled with different ideal monatomic gases. The mass of gas in each container is m, and the gases are at the same temperature. If the molar masses are m and 2m respectively, and R is the molar gas constant, which is true about the internal energy of the gas in each container. Right? Memorize the formula. Remember the number of mole is your mass, right? Mass of gas divided by molar mass. So for X, internal energy is X monoatomic. Monoatomic, your F is 3 degrees of freedom. And then your N and your mass is M. Molar mass is also M. Then your R, T, simplify it, get 3 over 2 RT. And for Y, the same thing, use the same formula, 3 degrees of freedom. You are told that your mass, same, mass is M, but the molar mass is 2M. That one there. Then you got RT, simplify it. Answer is A.
Oh, okay. 14 je.
Which graph represent the variation of internal energy with temperature of the ideal gas? Right. So get the correct formula. That's the formula. So ideal gas, F will be constant, depending on the gas you use. N is number of mole, constant. R is constant, so it's a straight line passing through origin. Can.
Oh, like that. So answer. Oh, can. Okay. Yeah, can je. And then number 2.
This one also not every time come out lah. Not every year will come out. Number 2. A cylinder contains 0.25 mole of oxygen at temperature 27 degrees Celsius. Assume oxygen gas as an ideal gas. You are given the molar mass of oxygen is 22 grams per mole. State 2 assumptions, 2 differences between ideal gas and real gas in terms of molecules. Right? There's no intermolecular force. Molecules collide elastically in ideal gas. Real gas, no. Real gas, there is a force of, there is intermolecular force. Okay.
Okay.
Or any others given in the, I think there are 5 assumptions. Others also can be used. Determine the mean translation kinetic energy of the gas molecule. Memory work. Kinetic energy is 3 over 2 kT. Right? You want translation. Translation is 3 degrees of freedom only. And put in your value. K is Boltzmann constant. Can get it from your data sheet. And then temperature change to Kelvin. Calculate out. Okay.
Oh, okay. Oh, this one straightforward question lah.
Yeah, straightforward. Memorize the right formula. Calculate the internal energy. Right? Remember, internal energy is just a sum of kinetic energy. So just now you calculate for one molecule. So calculate for one more now. Right? 5 degrees of freedom. Number of moles given. R is given. Get it from your formula sheet and change to Kelvin. Okay.
Go back again, je. Okay, never mind. Got it ready.
Okay, next question.
Chair 182, right? The section C, is it a derivation?
Section C, is it?
Yeah.
If one can see, they will ask you assumptions. 2 is derivation. You need to know how to derive.
Okay. 2 is a derivation. Okay, then.
So that one is just from your textbook, no? Step by step. 5 marks. Can?
Yeah, but the school teacher say like there is one derivation question, they'll ask one for sure. Confirm.
Usually they will ask for derivation. Now make sure you know how to derive the centripetal force formula. A equals to V square over R. Then this is one of them, no? Very few come out derivation.
No, but still have to memorize everything.
Yeah, you need to memorize the step.
Because yesterday also teacher gave list of questions like to do the derivation. He said sure come on one.
Make sure you know how to derive this. Okay, can?
Just go back in. Okay. Yeah, next one. B1.
The relationship between pressure and molecular kinetic energy, they are given you already. Pressure and kinetic energy. Calculate the average molecular kinetic energy for each helium and argon gas, which is contain a mixture of cylinder in equilibrium 150 degrees. Okay. So same formula, memorize the formula. Kinetic energy is 3 over 2 kT. Right? Helium is monoatomic, so it's 3 degree of freedom. Then put in your value. Boltzmann constant can be get from a data sheet. Temperature change to Kelvin. Then use your calculator. Determine the root mean square speed of the molecule. Oh, now you have to calculate. You have to calculate for helium and argon will be the same. Okay. Then you are required to determine the root mean square speed of each type of gas in B1 if the mass of helium is given that, mass of helium, mass of argon is given respectively. The same thing, no? Right? They have give you roughly that formula there. So root mean square, you just take square root of this one, no? Take the 2 across, take the m down, then take the square root, and put in your value, calculate out. Same formula, put in your value for argon and calculate out. Can or not? Describe the degree of freedom in a gas. Memory work. Degree of freedom in a molecule is the independent way a molecule can store kinetic energy. Kinetic can be stored as translational, rotational, or vibrational. Okay.
Okay.
Next question.
Okay. Question 2, 3, and 4. The C 3 and 4.
This one. Can see very
No, the other
popular.
one.
Huh?
No, the other one. The other one, 3 and 4.
Oh, 3 and 4.
C3 and 4. C3 and 4.
I think there's something wrong. Pressure exerted by ideal gas is given the formula there, and they ask you the meaning. So you just tell them, use the equation to derive the expression for internal energy of ideal gas in terms of pressure. So that is your, from here, you should be able to change the density to total mass. M is the mass of a molecule. And internal energy is just your total kinetic energy. So it's N times number of molecule and the C square. Then from here, you want your half. So you can times 2 here. And then divide by 2 here. So you got N M C square, which is this one. Then half. So you take the 3 across there.
How you do number 2 again? I'm confused a bit.
Okay, let me just okay, I want from here. Okay, from this equation, I can rewrite as 3 PV equals to NM Have I done something wrong? I just need to half this one, so it should be 3 over 2, sorry. I done something wrong. The internal energy is half NMC square. So I got my, from here, NMC square, I take my 3V across, I got this equation. So I half here, then I get this one. Any question? Have I done something wrong? Let me just check the answer. 2C. Two C. Okay, I think I've done something wrong here. This one should be 3, sorry. I have to do my correction, 3 over 2. No wonder, I was wondering why the answer given is wrong. Okay, so the answer given is correct. It's my careless mistake. Okay, I think because of a mistake there, there's also a mistake here. So the answer is correct. Okay, now anything not clear? My careless mistake, maths mistake. Yep. From here, I take the 3V
Okay.
and cross there, I get that. And I half this one to get the kinetic energy here. So I half here. So I get that. And you are asked to calculate the increase in internal energy. Do you guess when it expands from volume, this one to that one there? Okay, we have to change the new zoom soon. Okay, you just take a change in volume equals change in internal energy. Basically, you are differentiating, that's all. du equals to dv, that's all. I change it to change in volume and put in your value and get your answer. Determine the amount of heat to be supplied in the expansion above. So you have to use your first law of thermodynamics. Right, internal energy you have already calculated there. Work done is your pressure, that's your P, then change in volume. Right? And 10 to the power minus 3, 10 to the power minus 3, and work it out. Can. Then next question. I am careless. Yep. Any more questions?
Chapter 11 lah, Cher.
Chapter 11 I haven't done yet. Why you jump all over the place? You should be doing topic by topic.
I don't do topic by topic. I do like easy one.
Then how am I going to know what you want to ask? I just finished chapter 10. Haven't done 11 yet.
Oh, okay. Which one teacher did already?
I've done already except chapter 11.
Oh, okay. Then can do chapter 6, Cher.
Chapter 6.
No, wait. Chapter 5, the last one. Number 2, section C.
Chapter 5. I think we might as well take 5 minutes break lah. Easier. Take 5 minutes break.